When we work with fractions, it's important that we look at factors, the factors of numbers. What are factors? For example, what are the factors of 6? Well, the numbers which divide evenly into 6 are 1, 2, 3, and 6. These are the factors of 6. Each one divides in there evenly. Notice that they're always in pairs. 1 times 6 is 6, and 2 times 3 is 6. Now, the number 1 is a factor of every number, and the number 6, the same as the number itself. A factor of a number is always the number itself. And so when we are looking at factors in fractions, we don't need to use 1 and 6. It's the 2 and the 3, those factors that we need to look at, specifically the prime factors, the factors that don't have any other factors themselves other than 1 and themselves. The only factors of 2 are 1 and 2, and the only factors of 3 are 1 and 3. So those are called prime numbers, prime factors of 6. So let's look at 8. Well, 1 is a factor of 8, but we don't need to express that. 2 is a factor of 8, and 4 is a factor of 8. And of course, 8 is a factor of 8, but we don't need to work with that. We can discard that. 4 is not a prime number. 2 is prime. How many times will 2 go into 8? 4 times. Or the prime factors of 8 would be 2 times 2 times 2, or 2 to the third power, 2 cubed. 9. Exclude the factors 1 and 9, and the only prime factor is 3. The only prime factor of 9 is 3. And 3 times 3 is 9, so we can write that as 3 squared equals 9. Let's take a look at some others. Let's look at 16. Well, 2 is a factor of 16. 2 goes into 16 8 times. 2 will also divide evenly into 8. 2 goes into 8 4 times. And 2 also divides into 4 2 times. Now we have prime numbers 2 and 2 and 2 and 2, and those are the prime factors of 16. 1, 2, 3, 4. 2 times 2 times 2 times 2, or 2 to the fourth power. Let's look at another one, 50. What goes into 50? Well, 5 will go into 50. 5 goes into 50 10 times. 10 is divisible by 5 again, and 5 goes into 10 twice, and 2 is a prime number. So the factors of 50, the prime factors are 5 and 5 and 2, and so we can write the prime factors of 50 as 2 times 5 squared. Another way of doing this, sometimes what I just did here is called the upside down birthday cake, because the division signs kind of look like the tears on a cake. Another way of doing is what's called a factor tree. Let's start with 50. And 5 goes into 50 10 times. 5 is prime, so we can bring that down. 10 is the same thing as 2 times 5. And so we have our 3 primes here, 5, 5, and 2, so 2 times 5 squared. Same answer, just arriving at that answer by a little bit different method. We'll take one more. Let's do 120. We'll do the birthday cake method first. 2 goes into 120, 60 times. 2 goes into 60, 30 times. 2 goes into 30, 15 times. 2 will not go into 15, but 3 will go into 15, and that gives us 5 times. And so now we have the prime numbers 2, 2, 2, 3, and 5, and those are the prime factors of 120. 2 to the third power times 3 times 5 gives us 120. We could have done the factor tree, 120 at the top of the tree as we come down and make the branches. Let's do, this will be 4 times 30. We could choose any 2 factors we want. 4 is not prime. 4 is 2 times 2. And 30 is 5 times 6. 2 is prime. 2 is prime. 5 is prime. And 6 is 2 times 3. So here are the prime factors using the factor tree method. And so we have 2, 2, and 2, 2 to the third power, times a 3, times a 5. And so we can see that the 2 methods will give us the same result, the prime factors of numbers. And prime factors are important when it comes to doing fractions, and especially equivalent fractions.